All right, so we're going to be messing with the double angle identities. So instead of just sine of regular x, we'll have sine of 2x, cosine of 2x, and so on. So these formulas or these identities are something that you do need to have written down so that we can refer to them. We're going to use them in a number of ways. Honestly, like the sine of 2x and the cosine of 2x, these are the only ones that I happen to have memorized. Like this one's always stuck with me for some reason. But the reason that this one's kind of easy to recognize or to remember is because it's almost like our Pythagorean identity. I remember sine squared plus cosine squared equals 1. So it's a little bit like that, but it's the difference this time. But the thing to notice here is that cosine of 2x, the double angle formula for cosine, there's 3 of them. And although it's kind of like intimidating, like, oh my gosh, which one do I use or which one am I supposed to use? It's a good thing that we have 3 of them so that we're able to apply it in a number of ways. You'll see sometimes we use one versus the other, and it is handy. It's a good thing. So I'm just going to show real quick, how we get these other 2. These other 2 are actually going to come straight from the Pythagorean identity. All right. So remember, on the Pythagorean identity, we can move the cosine squared over to the right side, and so we could say sine squared is equal to this. Well, if you take cosine squared minus sine squared and replace the sine squared part with 1 minus cosine, you're going to get cosine squared minus, and then instead of a sine squared, we'll put 1 minus cosine squared. All right, what happens after you distribute the negative? Cosine squared minus 1, and then the negative and a negative here will make a positive cosine squared. So you end up with 2 cosine squared minus 1. All right, and that's that second identity that we have here. And to get the third identity, you do the same thing, but instead of writing a cosine squared, you're going to write 1 minus sine squared. So you might take a second and do that. I recommend it. That way you kind of see how this stuff all plays together. And I don't think we assigned it as homework or anything, but take the tangent of 2x here and try to get this formula. Again, all it takes is using the angle sum formula for tangent, but you're doing a plus a. So take a second and try that. See if you can use this formula to get that identity. All right, let's go ahead and we'll do a couple of easy examples for where these double angle formulas get used. The first place is simplifying trig expressions. Okay, so we know that sine of 2x is equal to 2 sine x cosine x, and we're going to use that to simplify this trig expression here. So I'm just going to replace this with a 2 sine x cosine x, and the bottom is still cosine squared. So then what we can do is cancel one of these cosines with one of the cosines down below. All right, and what we wind up with is 2 times sine over cosine, which is 2 tangent. All right, so we used it to take this rational trig expression and write it in terms of just one trig function. All right. We can also do something like this. All right. This time we're gonna swap out this cosine 2x for one of its many trig identities. All right. So I mean, you could just kind of guess and just try one, but the thing to look for on this, I would definitely be drawn to either the top one or the bottom one here. And the bottom one's pretty obvious because it's got sine x in it, or sine squared x in it, and you already have a sine squared. So that would be convenient. That's one thing you could do. But what I notice here is that if I use this the top identity, I have a negative sine x in it. And if I have a negative sine squared x and a positive sine squared x, well, those are going to fit nicely together. So that's what I'm going to do, is I'm going to use this top identity. So it's going to be sine squared plus, but instead of a cosine 2x, we'll say cosine squared minus sine squared. And then, of course, these two are going to cancel each other out. And so we're just left with cosine squared. All right. All right. We'll do some equations here in the next one and go from there.